We're going to take a look at some problems from the 2015 released SOL test in geometry, where we can use our ruler to make proportions and solve problems. I should say from the very beginning that this is not the advisable way to do the problem. It's normally much easier to just solve it. But if you're really stuck, it's a good way to eliminate some options and usually find the right answer. It can only be used on a few problems on the SOL, but at the very least, it's a good review in proportions. So if I were to take a look at this one, let's say I didn't know that I was supposed to use SOHCAHTOA to solve this problem, or I just forgot how to use SOHCAHTOA. Another way we can do this is to set up a proportion. So I have a side length, I have 15, and I'm looking for x. So I'm going to set up two fractions, and those are going to go in the numerators of my fractions. And then I'm going to take the ruler, and I'm going to use the centimeters ruler, which makes my life a lot easier because it will round everything to the nearest tenth. So whenever I round how big x actually is, I see that it's about 2.3. So underneath x, I'm going to write 2.3. And then I have to measure how large 15 is. Again, I'm getting the centimeters ruler. I'm going to rotate it around. Sometimes this takes a little bit of trying. Looks like I have it pretty close. So we want it to be as exact as possible. So it looks like that this is right about 6. So I put 6 under 15. And then I just cross multiply. So I'll get 6x is equal to 15 times 2.3, which is 34.5. Divide by 6. And I get an answer that's about 5.75. Looking at my options, the one that's closest to 5.75 will be the correct answer, which is D. Again, a much easier way to do this is just to use trigonometry with SOHCAHTOA, but let's say you forget how to do it. This might be the difference between passing or failing your SOL. Let's take a look at another problem that uses this. This is problem 31. That's the wrong number. So 31. Again, we can only use this with side lengths. So this problem, we can use it in a different respects. Is what is the length of KZ? So KZ is this entire length. So that's what I'm going to solve for. I don't even need to first find X and then figure out what KZ is. I have one thing here. Actually, I have two lengths. I have 2 and I have 5. It looks like 5 is going to be easier for me to measure, so I'm going to use 5. Once again, we get the ruler out. We go to the centimeters. So let's measure 5. That'll be the easier one because it's a vertical line. So we see that's about 2.4. So underneath 5, we're going to write 2.4. And then we're going to measure how big the entire length of KZ is. So the entire length of KZ looks like it's about 5.7. So whenever we cross multiply this, just like we did last time, and we solve it, we will actually get y is equal to 11.875. Whenever you actually solve this using the properties of circles, where you multiply the side lengths that intersect, we get the answer of KZ is equal to 12. So again, this is a formula that's not as easy to remember. So this is one where you might actually benefit from using the ruler. There are two other problems where this is an option. One is number 19. Number 19 is probably the least practical problem that you would want to use this on. It'd be much easier to use the congruent triangles. But let's, just for the sake of demonstration, show what we can do. Now notice that x, so before I measure the things, notice that x is the only one that I can solve for with side lengths. I cannot solve for y here because y is involved with angles. So at the very least, I can just solve for x. I have no idea what y could be. So the two things I'm going to use are 24 and 2x minus 6. So when I get the ruler out, the actual measurement of 24 came out to 6.4. And 2x minus 6 comes out to about 4.3. So cross multiplying this isn't exactly easy. Remember, we have 24 times 4.3. That's not bad. But it's going to be equal to, I need to distribute this, 6.4 times 2x minus 6. The purpose of this video is not to go through and solve the proportions. So I'm just going to tell you, once we're done with everything, we get x is equal to 0625. So that tells me that my answer is going to be either A or B. And whenever you actually solve this easier by using congruent triangles, you'll find out that the answer will be B. So that's a way we can eliminate some answers. Again, not exactly the best way to solve for this one. The last one where we could be tempted to use proportions is number 45 on the release test. This one is actually not drawn to scale, and unfortunately there's no way to see that. So what we're looking for in the problem is it says which is the closest to the width of the base. So this is like x down here. So I have 505 and I have x. So let's start by measuring what x is. X is about 1.2. And whenever we measure the height, it would make sense to measure this right here, because it's saying this is 505. So we get 8.1 as the height. Whenever we cross multiply this, we're going to have a problem though. We get x is about 74.8. So if you were looking at these options, probably this one would be the most tempting, D. None of them are really that close because the picture's not drawn to scale. The actual answer is B. So you actually need to do this to solve. This picture is not to scale. Again, this should be an option that's only used as a last resort. That problem with the circles is one where I think this would be a practical option to use. It's also a good way to maybe check your answers. You always want to make sure visually that your answer makes sense. So even if you're not using the ruler, you should be thinking in your mind, does this make sense in terms of the size I got based on the picture? I hope this is helpful, and please watch the other videos for additional hints to help you on the SOL.